The purpose of this lesson is to learn about cross products, aliases, natural joins, inner, left, right, and outer joins, ordering and grouping, aggregate functions, literals, and subqueries. In a previous lesson, we worked with the Classic Models database, which is officially known as a schema, and we performed some basic queries. So our basic queries are always going to be in the format of select something from a particular table. So I want to select everything from our orders table. So that's our basic query. It gives me everything that's in that table, and I can narrow it down. So if I want to see everything that was on a particular order, I can say where order number is equal to 10100. And that allows me to narrow it down. That's a very basic query that exists only inside of one database table, and that the whole point of a relational database is to be able to get information from multiple tables. So we will actually build up to getting information from more than one table so that we can form a relation between them. So the first thing I need to show you is if I want to select information from more than one table, all I'm going to do is select everything and then still do my from, but I want to see everything that's in the customers table and the orders table. Now, this is not going to function exactly like you expect, and I want to show you something real quick. I'm going to do a select statement from customers. Okay, there were 123 rows. And I'm going to do another one, which is select everything from orders, and there are 326 rows. So what I want to do is I want to perform a query that will look at both of those tables, and what I'm expecting is that I want to see for every customer that's there, I want to see all of the orders that they've placed. So what I expect to happen is I expect to see 326 rows come back that list our 123 customers in it. So if I run this, I get a lot more than that for some reason. I get 1,000. The reason for it is the way that this works is it will take every single record from this customers table and merge it with every single record over here. So in reality, what I actually get is 123 times 326 rows. So a lot more than what I really expected to happen. Okay, so what I want to do is I want to find some way to narrow this down. So what I have to do is I have to find what relates the two tables. Alright, if I look at our customers table, every customer has a customer number. And if I look at our orders table, the customer number is listed with every one of these. So I'm going to do what's called a natural join. Now what a natural join is I'm going to use the where clause, but this time instead of saying something like where customer number equals 103, I'm going to say where the customer number in the customers table matches the customer number in the orders table. In the last lesson I showed you how to do a fully qualified table name, and we will have to use that for this to function. Okay, so what I'm going to do is I'm going to say where customers dot customer number is equal to orders dot customer number. Now when I run this, what it's going to do is it's going to perform these two individual queries, and it will get these two lists. But now what it will do is when it puts the two of them together, it will only show the records to me where the customer number matches in both of the tables. So if I run this, I now get 326 rows back. So now what I see is customer number 326, who is this person, placed a particular order on a certain date, and it was shipped and so forth. So it gives me the ability to see what information I need. Okay, so now what I really want to see though is I want to see the order number, the customer name, the date that it was ordered, and the date that it shipped. Okay, so what I want to see is I want to select we're going to do order number first. So orders dot order number. Okay, so I want to see the order number, the customer name, and the customer name was under customer. So I'm going to say customers dot customer name. Okay, and I want to see the order date, which is in the orders table. So orders dot order date. And I want to see the ship date. So orders dot shipped date. So we actually have to fully qualify these for it to work. Otherwise it'll get confused and not necessarily know which table these records should be coming out of, or the attributes should be coming from. So now I'm telling it I want to see the order number, which is in the orders table. I want to see the customer name, which is in the customers table. I want to see the order date, which is in the orders table, and I want to see the ship date, which is in the orders table. From both of those tables, where the customer number value matches in each of those tables. So when I run this, it will narrow it down, and I just simply get those 4 columns that I requested. Alright, so I want to make it look a little bit nicer. So what I can do is I can use a special keyword called as. And what happens is right now I see order number and it's all together as one word. And I see customer name and it's all together as one word. Well, I don't want it that way. I want it to actually say order space number. So what I'm going to do is up here where I select, when I list my columns, I'm going to put a space, the keyword as, and then what I want it to be. Now I want it to be order number, and I want order number to have a space between it. So I have to put it in single quotes. So I'm going to say order number, and then now I'm going to do the same thing with customer name. So I'm going to say as. Same thing with the order date, as order date, and notice that I'm putting it in single quotes. I accidentally put a double quote there. Okay, and then orders dot shipped date as shipped date. So now what this will do is it will change what the text is up here to whatever I put in my actual query. So now it looks more like something that is user-friendly. It's more like what I expect to see when something prints out. That was a lot of typing, and I don't really want to have to type all of that. So I'm going to use what's called an alias. And essentially what I'm going to do is I'm going to shorten the name of the customers table. And the way that I'm going to shorten it is I'm still going to list that it's the customers table, but I'm going to put a space and then the letter C. And then over here for the orders table, I want to shorten its name, so I'm going to put a space and then an O. And I could call it Bob if I wanted to. It doesn't matter what I call it. But what happens is by doing it this way, I now have actually done away with the customers table, and I only have a C table as far as this query is concerned. So what that means is any place where I see orders, I have to change that to O. Any place that I see customers, I change that to a C. There's an order, so we get rid of everything else. And another orders. Okay, so now that shortened that, but I also have to do the same thing down here. And now what I have just done is by creating an alias, I have significantly shortened the amount of typing that I need to do. So C is customers and O is orders. So we're selecting the order number from the O table, which is actually orders. We're selecting the customer name from the C table, which is actually customers. We are selecting order date from the O table, which is actually orders. And we are selecting the ship date from the O table, which is actually orders. And like I said, what we're doing is we're shortening it, and I'll show you in a minute why this actually becomes more helpful. So I'm going to run this query, and I will get the exact same thing sent back because I used the alias and I changed all of my references to reference the alias and not the actual table name. So in this example, I could have left it as the customers and orders table. I don't have to use the alias. So the question is, where do I have to use an alias? Alright, so there is this type of join called a self join. Sometimes you will have to relate a table back to itself, and an example of it would be if I have a list of employees and some of my employees are managers, then if I want to see a list of the name of all of my employee along with the name of his or her manager, I'm going to have to do a query that will look back inside of that table. And you can't do that type of query with a regular join. You can't just simply state I want those two tables. It's just strictly one table. So what I have to do is I have to give the table an alias name. So what I'm going to do is I want to do a query where we select our customer name from customers, and then let's go ahead and run this. Okay, so now this gives me the name of all of our customers from our table. And I want to have the customer name listed one time, and then I want to have it listed again beside it. Now notice we have 123 customers. So if I were to do something like from customers, comma, customers, it won't let me do this. It will not give me the correct number of rows, or it could throw an error, just depends on the way the database is designed, but this won't work. So instead what I am going to do is I'm going to tell it that I want to use this table twice, but I'm going to call it A, and then this one I will call B. And so now what I can do is I can say I want to see all of the A.customer names, and then comma B.customer name. And so what this will do is it will show to me all of the customers that are in the A table along with all the customers that are in the B table. Okay, so this is a natural join. I don't have a where clause, so what this would mean is that I would have 123 times 123 rows, which is significantly more than the customers that we really have. So what I need to do is I have to provide a means to join the two tables together. So even though they are technically the same table, logically the system thinks that they are now two different tables. We have table A and table B. So what I have to do is a where clause, and I'm going to say where A.customer name is equal to B.customer name. And then when I run this, what I will get is 123 rows with the customer name listed twice. So notice I have customer name and customer name because that's the real name of the column. It doesn't tell me that it's A.customer name and B.customer name, which it really is. This is our A column, and this is our B column over here. So what we're looking at is a self join where I have treated the table as if it had two different names, and then the system will think that it is actually two separate tables. Now the way that I have constructed this join is actually the old-fashioned way to do it. This where clause here, where you say where something in one table is equal to something in the other table, this actually is not the way that we do it anymore. What we would use is what's called an explicit join. And so what I want to do is I explicitly want to join these two tables together. So I'm going to use the word join. And so what I'm doing is selecting these two columns from the customers table that I'm calling A, and I'm going to join it with the customers table that I call B. And then now I need to tell it that I am trying to join the two of these together on a particular relationship. So I'm going to say on A.customer name equals B.customer name. Notice the way that I form the relationship is the same here, but the way that I call the two tables in is different. So the question is, why do I do this? Alright, in the first example that I gave to you, if I were to do it where I say select from those two tables and I just left it alone, I had 123 times 123 rows. Well, that's the way that it combines every single every single row with every other row in the two tables. In an explicit join, it is actually more efficient. The system will not form that big table and then narrow it down. It just starts off by building the relationship. So this will actually be a more efficient join. When I run it, I will get the exact same thing. There are actually different types of joins. This one is what's called an inner join, and I didn't actually type the word because you don't have to, but an inner join is the same thing the same result as a natural join. And essentially what it says is that if the value in the one table matches the value in the other table, then the result will be shown. Alright, so that may not always be what we want to happen. So I'm going to run this with the word inner in it, and you will see that I get the exact same thing, because like I said, the inner keyword is optional. You don't have to list it. But we have inner, we have left, we have right, and we have outer joins. And the difference is going to be how it actually displays things to us. Okay, so an inner join is only records where this thing is true, where the customer name exists in both tables, will be displayed. The problem is I don't list all of our customers here. So what I want to do is I want to make a query where I can select all of our customers and all of the orders that they have made. And I want it to show the customer name on the left and then a list of all their orders on the right. Alright, so what I want to do is I want to select things from our customers table and things from our orders table. So what I'm going to do is select customers.customer name, and then I want to have that mixed with orders.order number, and then orders.order date. Okay, so now what I'm doing is I'm actually trying to form a relationship between these two tables, and just like I started out with before, I'm actually causing myself more work because I'm leaving the full name of the table. So we'll start using an alias here in a minute. Alright, so what I want to do is I want to get those from the orders table and then comma from the customers table. Okay, but I said this, if I do it in this manner, this is a natural join and it's not as efficient. So I actually want to use the join keyword. Okay, so select the customer name from the customers table, the order number from the orders table, and the order date from the orders table. Alright, now the thing with this is, if I run this, it's going to show to me all of the orders for all the customers mixed together with every single record. So we still have to provide our on condition. And what I'm going to say now is where orders.customer number is equal to customers.customer number. Okay, so what this will do is it will look at these two tables, orders and customers. It will find all the records where the customer numbers match, and then it will show the information to us. Alright, so now you'll see that we have 326 rows because we have 326 orders. And I would really like to have this ordered by the customer's name. I'd like to have it in alphabetical order. So I'm going to add to the end of this one more keyword, which is order by, and then what row do I want it to be ordered by? So I want it to be ordered by customers.customer number. Alright, so run this. Now they're in alphabetical order. Okay, so I'm sorry, I put it customer number. I want customer name. Now they're in alphabetical order. Alright, so now if I list these customers by customer name, this all works. But the problem is I've typed out customers and orders, and I want to make it easier on myself. So what I am going to do is I'm going to get in the habit of the first one here is going to be considered our left table. So I'm going to put an L. So our alias for this one will just simply be L. And our customers table, I'm going to imagine this one being the one on the right. So if imagine I put these two tables together side by side, I have one on the left, one on the right, then what it does is makes it easier for me to figure out what stuff I need out of each of the tables. Okay, so what I want to see is I want to see all of our orders from this left table mixed with all of our customers from the right table. And so now instead of customers I have R, instead of orders I have L, orders is L, orders is L down here, and then customers is right here, and customers is right there. Okay, so now instead of saying customers and orders, now what I want to think about is the orders table being on the left, the customers table being on the right, and what information do I want out of the two of those. Okay, so what I have right now is I told it that I want it to select information out of the two tables, but only show the information to me on customers that have actually placed an order. Because for the person to show up in here, they would have to have a customer number in both tables. And if a customer has never placed an order, they're not going to have a record that has their customer number in it. Okay, so what I can do is I can modify my join just a little bit. And so I want to see a list of all of our customers, regardless if they have ordered something or not. And the customer table is on the right. The orders table is on the left. Those are important, trying to figure out which one's on the left and which one's on the right. Okay, so I need to think about, do I only want to see all of the orders or all the customers that have placed an order? And that's it. Or do I want to see all of the customers regardless if they placed an order or not? Or do I want to see all of the orders whether or not they have a customer listed? Or do I just simply want to see the customers that don't have an order? And those are my options. Okay, so if I look at this from the left side, if I look at the table on the left being the orders, and I want to see all of the orders with all of the customers, regardless if there is a customer for each order. Okay, so what I'm going to do is I'm going to type the word left here in front of join, and a left join will take this orders table. I will get every single row that's in the orders table, and if there's a corresponding customer that matches this criteria, it will list it. If there's not a corresponding customer, it will have null values. Okay, so now I know that every order has a customer listed, so I'm going to end up with the same result that I have right now. Still get 326. But if I look at it from the other direction, if I go right join, if I look at it as a right join, I want to see every customer that we have, regardless if they've placed an order or not. I want to see them. And if they placed an order, I want the system to show the order to me. If they didn't place an order, then we're just simply going to see some nulls beside it. Okay, so we have 326 rows when we just looked at it from the order side. If I run it from the customer side, I have 351 rows. Okay, because now what I can look at is I can see that American Souvenirs Inc. has never ordered anything. ANG Resellers, they've never ordered anything. So now what this is doing is showing to me every single customer that we have, regardless if they've placed an order or not. Alright, so the purpose of this is, what will happen a lot of times is we end up losing customers. Let's say I had a database table where I had all of my customers listed, and I had another table with our representatives, and for almost all of our customers we list a customer representative. Well, if that customer doesn't have a representative listed and I do a query to find all of our customers along with the representative names, the people that don't have a rep won't show up in my list. So effectively I end up losing those customers. By doing this, what I'm doing is I'm making it where I won't lose any customers. All of my customers show up regardless if they placed an order or not. So the next thing that I want to play with is what's called an aggregate function, which is technically going to be our sums and averages and counts and max and min and things of that nature. So I'm going to go back to query 1 and I'm going to remove those. And I want to see how many customers we have. And the way that I would do this, if I want to see a list of all of our customers, I say select everything from customers, and then I run that, and I get a list of all of our customers. But if I want to see how many customers we have, then I'm going to add the word count, and then put the asterisk inside of a set of parentheses. So now what this will do, if it's just select count, is it will select all of the customers and then just see how many of those we have, and it provides an output like this. Alright, so I don't want it to say count, so I will want it to say something more like as number of customers, and then run this, and I get my result that looks like this now. So I get a nice heading on it. So now I can look at this list and see I have 123 customers, which just happens to be the exact same number of customers that we had when we did the query, and it told us so many rows were returned. The same thing would be true. Instead of using the customers, I want to see from order details. And so I could say the number of orders, order items actually, because it would be how many items were on each list. And so now I can see that 2,996 items have actually been ordered. So the count just simply gives me a way to see how many records exist in a particular database, in the particular table, and then we can do some other functions with that that would allow us to count things even better. Alright, so let's look at everything that is in the order details table. So when I run select everything from order details, I will see all of these orders. Now what you will notice is that our order numbers are repeated and our product code is different. So what they've done with this table is we have a composite key with order number and product code, so these two columns make up our primary key, and then it lists how many of that particular item were listed or were ordered, and then how much each one was, and then what order was it on the receipt. Alright, so what I want to see is I want to see for each ticket or for each order how many items total were ordered. Okay, so the way that I want to do this is I want to count how many things were in the quantity ordered for each of the things that are in here. Now the way that this works is if I just run this and I say count how many things were ordered, it'll just simply tell me how many rows there are. So if I run this, it just says 2,996. So the same thing we had before. So I want to see my listing here. I want to see how many things this particular person ordered. And so what I can do is I can narrow this down a little bit. I want to see how many things he ordered. So I could say where, let's see, it is order number 10100. So order number is equal to 10100. So now what I can do is run this and it will show to me how many different things he ordered. It's not showing me how many quantity he ordered. It is showing me how many rows he has of things that were ordered. So what I can see is he has 1, 2, 3, 4 different things that were ordered. Okay, so I want to add up how many things he actually ordered. So instead of doing a count, because count just says, hey, there's 1, there's 2, there's 3, there's 4 things, I want it to actually add these up. So I'm going to change my keyword from count to sum. And by doing sum, it will add up all of the item or the values that are in the quantity ordered for this particular person. And so now I can see that he ordered 151 items total. So the count will tell me how many how many records he has. The sum will tell me how much the total is of the values that are in those records. I want to make this a little more user-friendly, so I want to see what the order number was. And so I'm going to add another column here called order number and then run this. So now we see order number 10100 is the sum of this much. And what I could do is I could add another column here, and instead of letting it pick a column, I'm going to give it a literal. And what I'm going to say is that I want it to put some text into the records field, and then that way it will just be that one piece of text. So I want it to say total. So I'm going to actually put total in single quotes here. So this is a literal because I'm telling it is a text string. And I'm creating a new column here called total, and what it will do is for every item it will actually have the word total. Okay, so maybe I want to have total with a sum or with a colon, and that way I can make something that looks kind of like a record. Alright, why would I do this? I might want it to be something like on this order he had so many things, and then I could put equals, and then I could have other things that show up in between that make it where I can look across the record and see more information other than just numbers. So I can actually make it a little bit more usable. Alright, so I want to do this for everybody though. So if I do this, if I add up the sum like this and I leave off who we're doing it for, it is going to do the sum for everybody's quantity ordered, but it will only show us the first record for order number. And the reason for this is because I didn't specify to do an aggregate function, which aggregate means to do it with more than one record. So I'm not telling it to do anything with more than one record, so it just returns the first result for the order number, but it will do the aggregate function for the second one. So total, there were 105,000 things that were ordered for all of the orders that we have. I want it to show to me how many things each order had on it, and I want to see every order and see what they ordered. To do this, I need to use another keyword called group by. Okay, so what I'm going to do, and this requires an aggregate function for this to occur, but I'm going to use the keyword group by, and I want to group it by the order number. Now what I'm doing is I'm telling it I want it to figure out all of this stuff for each order number that's out there. And so when I run this, I will get a list that says order number 10100 had 151 items on it. Order number 10101 had 142 items on it. And as I go down through the list, every single order that we have, this will show to me how many things they actually had on their order. So now what it's doing is it's making it where instead of showing me the 4 different records that they had for 10100, it's just showing me one result, and I can know how many items were on that particular ticket. I want to make this sum column look nicer, so I'm going to use the as keyword, and I want this to be num ordered. Okay, so now when I run this, now this says num ordered. This one says order number, but I want that to be a nicer, so I'm going to say as order number. Run this, and so now I see total, order number, num ordered. I don't necessarily need this total column anymore, so we can go and get rid of that. And so now we just get something that looks more like this. Alright, so I want to see which ticket had the most stuff on it. There are a couple of ways I could do that. I can group by the order number, but then I can also order it by, and this is where we're going to use it to put it in alphabetical or numerical order. Okay, so now my order by, I'm going to say by quantity ordered. And so now what happens is it will still give me this result, but now it will be in order by num ordered. Okay, so it is giving to me, it's giving the results to me not for the aggregate function though, it's giving the results to me for the individual items that are in the orders. So this particular order here may have an order that has one thing in it. So the numbers here are not necessarily representative of what is ordered. It's representative of the sum of all of those ordered items. So if this column here is an aggregate function and I want it sorted by that aggregate function, I have to do the same thing here. I'm going to do order by and then by the sum of the quantity ordered. And so now when I run this, now they are in order based on the number of things that everybody ordered from least to most. Now this is called ascending order. Ascending is starting from the smallest number and going up to the largest one, and that is actually the default. But if I don't want to do ascending order, what I can do is right after my aggregate function, I can put a space and then I can tell it that I want it to be in descending order, D-E-S-C. And when I run this, now it will put the order that has the most at the top, and then it will go down to the smallest at the bottom. we do also have other aggregate functions. What I want to see is for our quantity ordered, I want to see who had the most items on a single ticket. And so what I'm going to do is I'm going to change my query that I want it to select the max number of quantity ordered from the order details table, and then run it. So what this will show to me is that the highest number in the quantity ordered column was 97. I can do the same thing with min, and that will show me the lowest number that's in that column, which is 6 in this case. I can also do mathematical calculations. So if I look at this table, I can see that for this particular order, we have the number of items that were ordered and the price each. And I want to see how much it would cost for those 30 items. So what I'm going to do is I'm going to tell it to select everything that's in this table plus another column that I'm going to make up, which is just strictly a calculation. So I'm going to say quantity ordered times price each as, and we'll call it total. So what I'm doing is I'm leaving all of these columns, plus I want one more column over here that will be called total, that will show me how much the total is for those items. So when I run it, 30 times $171.70 is $5,151. This will allow me to do calculations for things that actually aren't recorded in the table. So the total does not really exist in the table. It is just strictly existing in this table that is in memory. The real table that's on the hard drive does not include that. Those are called calculated values. We can get a little creative with this. I want to go a little bit further, so I want to select the product code, and I want to see how many of that particular item are ordered. So what I'm doing is saying select the product code and count how many of those were ordered from order details. And what I want it to do is I want it to group based on the product code. So I'm going to group by. Okay, so now when I run this, what I will get is for each product that there is, how many of them are ordered. So now what I want to know is I want to know what the sum of the price was for all of those items. So for each one of these that was sold, what was the sum? So I'm going to add another column here, and we're going to call it sum of price each. So now what it will actually do is it will figure out how many of these were ordered, and then it will add up the sum of the price for each one of those, and it will list it here. So now every one of these is accounted for in this $2,817. Now if you notice, it goes off to the 6 out here. There is a little bit of mathematical error that is allowed in MySQL, and we have the ability to truncate these, which we will start doing in future lessons. I want to go a little bit further with this, and I want to find the total number of items that were ordered on each ticket and the total price for each ticket. Okay, so if I were to simply select everything from the order table, from the order details table, and run it, I can look at this and I can see that, okay, this item here, or these 3 make up one ticket, sorry, these 4, and this is how many things were on it. So if I wanted to find out how much this ticket was, I'd have to take 30 times $171.70, stick that in a row over here, do that with all 4 of these, and then add all 4 of those together. I really don't want to do that, so what I'm going to do is I'm going to let SQL do it for me. Okay, so I want to have the order number, and I want to get the sum of the quantity of things that were ordered on the ticket. So I want to know how many things were ordered. So we're going to say sum of quantity ordered So sum of quantity ordered. And then I also want the sum of the quantity of things that were ordered times the price of each thing. Okay, so the quantity ordered times price each. And I want to call this total. Okay, so now what I'm doing is I have to have a group by for this to work. So I have an aggregate function, but I have to group all the stuff that's in this order number together for it to allow me to do this kind of thing. So I'm going to say group by. Alright, so what I'm telling it is to list the order number, but I want it to take all 4 of these and clump them together. But before it does that, I want it to figure out the sum, so how many things were ordered. And before it clumps them together, I want it to figure out the quantity ordered times the price each for each thing. So imagine me having another column over here where it says 30 times 171 and stick it over here. This one does that. Then after it does that for all 4 of them, I want it to add that all together. Then I want it to add up how many things we have and then clump it all together into one entry for this particular record. So when I run this, now I get something like this. So for this particular order, they had 151 items on the ticket. The total ticket price was $12,133.25. And now I can look down through this and look at each ticket and see exactly what the total is. Now this value and this value do not actually exist in the database table. They are strictly calculated values that exist in memory. We can also perform what are called subqueries. Now a subquery would be the same as if I were to perform a query to get a value and write that value down and then use that value to perform a lookup. So let's say I want to see all of the people that have placed an order where the number of things that were on their order is greater than the average number of things that everybody has ordered. I can do that. Alright, so what I want to do is I want to select the average number of things that are ordered, so quantity ordered, from order details. Okay, so this is the basic query. I'm going to run it. So the average number of things that exist on a ticket is 35.1572. And I want to see all of the orders that have more than that stuff on their tickets. So what I can do is I could construct a query that says select order number, product code, and quantity ordered from order details, where the quantity ordered is greater than, and then I have to know this number, so I'm going to write 35.1572, and then I want it to be ordered by order number. Okay, so what I'm telling it to do is to go through this order details table. I want it to find all of the orders where the amount of stuff that's ordered is greater than 35.1572, which I just found out is the average because I performed that query, and then order it by the order number. Okay, so what I can look at is that all of the things that are in this list should have more than 35 items on the ticket. The problem is our average would constantly change for this example, so I'd have to figure out the average every single time I want to run this query. I don't necessarily want to do that. So instead of performing this query separately, I can actually put this query in the place of where I put the value here. So what I'm going to do is I'm going to press enter and then insert. And this is actually going to go inside of a set of parentheses. So what I'm going to do is that query that we ran before is actually going to go right here inside of the parentheses. And then what that will do is it'll allow me to run it, trying to make it line up so it looks nicer. So instead of saying the 35.172, I'm going to let the system calculate it. So what it will do is, just like in math class, it will do the stuff inside of parentheses first, and then after it calculates this, then it will put it in and use it as part of this calculation. So what will happen is when I run this, I get the exact same results because the system will calculate this inner query first. Then once it calculates the inner query, then it will put it here and then perform this outer query. This is what's called a subquery, or it also is called nesting. We have another table over here that we haven't played with much, so I'm going to start playing with that one. It's called the payments table. So I want to select everything from payments. And here's our payments table. Now what the payments table is a list of all of our customers, and it will allow us to see which customers made which payments. Okay, so what I want to do is I want to see for each particular customer how much money they've paid. Sorry. What I'm going to do here is I'm going to do an aggregate function so that I can see for each customer how much money that they've actually paid out. So I don't care about the check number and the payment date for this example. So what I want to see is customer number, and then I want to see the sum of all of their amounts. Okay, now the thing is, for this to work, I have to have a group to clump this together into a sum. So I'm going to say group by customer number. So I want it to group everybody by customer number. So take all of these 103s and add the payments together, and then just simply list the customer number along with the total. So if I run this, I get customer 103, and there's the total for his or her account. So what I want to see is only the people that have made a payment that is more than the average of all of the other customers. So what I can do is I can make a where clause, and I want to say that the amount that this person has paid is greater than the amount of money that everybody else has paid. So once again, we're going to use a subquery, and I'm going to let the system automatically figure out the average for me. So I'm going to say from my inner query, I want it to select the average of the amount that was paid for everybody from the payments table. So what I'm doing is I'm telling it select the average amount that everybody has paid from the payments table, and then up here I only want to show people to me that the amount that they paid is greater than the average. And once again, it's still grouped by customer number. When I run this, I now get less people. So originally I had 98 records that were listed. Now I only have 75 because only 75 people actually made a payment that was higher than the average for everybody else. Now notice I told it where the amount of an individual charge, not the sum here. So if they made 4 different payments, it's looking at the average of all of their payments, not the total. In this lesson, you learned about a cross product, which is a function of relational algebra. You learned about aliases, natural joins, inner, left, right, and outer joins, ordering and grouping, aggregate functions such as sum, average, min, and max, literals, and subqueries.